everyone, in this video I'd like to talk about creating objects. Now there is a prior video in this playlist that talks about objects and discusses some of the ones that come in Java, such as math class and random. We've talked about scanners and strings as well, but today's the day where we're actually going to talk about creating our own objects. Now, because we have talked about objects, I want to do a little review and remind you of the word classes. So a class, by definition, is a template that defines what an object's data fields and methods will be. And so when we talk about data fields and methods, these are things that the object is, like what its properties are and what it does. You can create many instances of a class, so we've done that with scanners before, where there's multiple instances of scanner. You can think of instances as like versions. So creating an instance of a class is known as instantiation. And I guess one more thing to point out here is that when you write programs in the Java language, all that program data that you have is wrapped in a class because Java is set up in this particular way. Some new vocabulary for today is this word constructor. A constructor is kind of like a method. It's a new kind of method which is invoked when you create a new instance of the object, instantiation. It can perform any action, but constructors are designed to perform initializing actions. For example, giving values to data fields of the object. And of course, one of the examples that we've seen before are scanners. So if I create scanner scan, and then I use the keyword new, that creates a new scanner object. And as you may recall, in here, various things can go depending on how we want that scanner to work. It could go from system.in if you want to read from the console, or we can use file input if we want to read from a file instead, right? So when I've created this new object of scanner named scan, it has these various fields that I ascribe to it to create it. To make creating objects a little bit more concrete, I'm going to use an example running through these slides of a deck of playing cards. So we'll just start with a card. If you are not familiar with playing cards, there are 4 suits, and those suits are called clubs, diamonds, hearts, and spades. Diamonds and hearts are normally red, and clubs and spades are normally black. So that's normally how the cards are colored. We'll see an example in a moment. And just, I usually think of these cards as being in kind of an alphabetical order, so C, D, H, S. And so we will use CDHS later on to describe cards. Along with the suit, there are values that the cards can have, which go from 2 up to ace. So the numbering is like 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have these cards that have kind of these special names given to them, which are Jack, Queen, King, and Ace, but it's totally fine to think of this as 11, 12, 13, and 14. Normally, these cards, although I wrote values, another way to call it is ranks. There are 4 suits and they have 13 values, and so there are 52 cards total. And you may also hear me refer to Jack, Queen, and King as face cards. So here are some examples of those cards. You can see here that I have the 6, and then there are hearts drawn on this card. So this is the 6 of hearts. And then here I have a 3, and then diamonds, so 3 of diamonds. Here's 7, and then 7 clubs, so the 7 of clubs, right? So this is normally how we talk about cards. We say what that number is, and then we say of what the suit is. Good. So as we're thinking about this, remember that we want to turn this into a Java object, and the two properties that I know that my cards have are going to be this rank and this suit. So let me go ahead and develop this card class. And the constructor for card class looks just like this. Public class card, private int rank, private int suit, and then this constructor is public card, and then in parentheses int rank char suit, this dot rank equals rank, and this dot suit equals suit. Let's break down that code a little bit more. Constructors are really similar to methods, but they create a new version of the class, and they must be named the same as public class whatever, and they have no return statement. So looking again at the little piece of code I wrote, the class that I have here is called capital C card, so it's public class card, and this file, by the way, will also be card.java. And then there are these class variables that go with them. And then underneath, I have this constructor. So the constructor has the same name. It's public card, and it kind of looks like a method, but it has no return statement. And it has some values that go along with it, which in this case are rank and suit. You might also notice the use of this new keyword, this. The keyword this refers to the object itself. It can be used inside the class to reference the class's defined variables. So in the code that I have, the private class variables that I shouldn't actually see are called private int rank and private char suit. And then inside the constructor, I also have rank and suit. And so basically, I want to make sure that those private class variables are set to the ones that are also defined in the constructor. Another vocabulary word that we have for today is shadowing. Shadowing occurs when a local variable or parameter has the same name as an attribute. And a question that you could get asked is, well, what keyword does Java provide so that you can access instance variables using shadowing? The answer is this. The next thing I'd like to talk about are getters. So far, we've talked about having these private class variables and then using the this keyword inside the constructor, and the rank and suit written on the right-hand side are the ones that go with the parameters in the constructor. But since the class variables are private, to be actually able to see what they are, you want to use these things called getter methods. And so they're literally named get whatever, get suit, and get rank. But what you'll notice is that they return the suit value and the rank value, which we need for card. The next method that I want to talk about is the toString method. So you can see down here I've written public string toString and then return rank of suit. And then here I have an example of a card, which is the 6 of hearts. And earlier I described the cards as being of type of having suits either clubs, diamonds, hearts, or spades, and that was C, D, H, S. And so that's actually the reason that I have the suit as a char here. So the way that this toString method would be written is 6 of H, following how I've written the toString method. Now, it turns out that toString is something that Java provides for all objects as a standard. But objects are complex data types, like arrays, and Java doesn't actually know how to print them. So I wrote my own toString method, but there's kind of a standard way that Java does toString, which actually looks like this. So it's public string toString return getClass.getName plus an @ plus integer.toHexstring hashcode. And so for a card object, it would actually be card at some hex string. So what's happening, like we had with arrays, is Java is just printing the memory address because it doesn't know what to print otherwise. Now, Java will use a class's toString method if it has one created. So you can override the toString method, as I did. So rather than having it return like card at 15df3, I have it return rank of suit. So a recommendation to you, when you're trying this out, let's maybe think about writing a better toString method. For example, you maybe want to have it return something that looks like Jack of Spades instead of 10 of S. So having it write out like the whole word and even the names of the cards if they have it would be a good way to practice writing a toString method. So now at this point we've gotten far enough with the description of the class, the constructor, and the various methods that go along with it that we can start talking about a UML diagram. Now, a UML diagram is just a way to write down, like on a sheet of paper, what's going on in a class. So all it really does is like take a box and then split it into 3 pieces. So that's what these lines are. So it's literally a rectangle and then line here and then a line here. And then at the very top, you have whatever the name of that class is. And then the things that are private to that class, which are int and rank, which is an int, and suit, which is a char. And you can you use a minus sign to indicate that they're private. Things that are public, meaning that it's visible to other programs, are card, which has the constructor associated with it, get, suit, get, rank, and toString. And I've used a plus sign here to indicate that they're public. Another descriptor other than private and public can be protected, which means it's visible in the class and any subclasses, but I just want to let you know that that word exists, but we won't be talking about it for now. Here's another exercise I'm going to leave you with, which is to write a compare to method. A lot of times if you're playing cards, you have a couple of them in your hand, and you might want to put them in order. So you actually will sort them, and to do that we need a way to talk about what card is less than or greater than another card. So here I'm going to say that that all clubs are less than all diamonds, which are less than all hearts, which are less than all spades. And then within a suit, you want to compare it by number, starting at 2. And so here, let's just think about if I have 2 cards, maybe what do the if statements look like if I want to return, let's say, -1 if card 1 is less than card 2, 0 if they're equal, and 1 otherwise. So I'll leave that as an exercise for you. The next thing I want to talk about is class methods. So just more vocabulary, a class method is the same for all copies of the class, but unique to the individual objects. I'm going to show a few more examples besides card, which we've seen a little bit of already. A book object might have get author. A card, of course, has get suit. And maybe you have an employee object and you can add skills to that employee. So we can do add skill Java. And so every card object has a get rank method and a get suit method, but the value can be different depending on the card. And similarly, every instance of book has an author, but it can have a different result for every book. And then employees all have some skills, and this particular employee now has Java as one of their skills. All right. So the last thing I want to talk about is the fact that objects can be null if you don't set them equal to anything. So in this little example, I have an array of strings, and arrays are an object, so are strings. So I've set this array of blanks to new string 5, and I've set blanks at 1 equal to something and blanks at 3 equal to something, but not anything else. So now if I run this, it's going to print out null, and then I set 1 and 3, so Grace, null, Hopper, null. But
because things are null, I actually can't apply any methods to these null objects, which it would otherwise have. So strings have two uppercase associated with them. But if I try to run this, it's going to give me this exception. It cannot do string.toUpperCase because the value itself is null. So we can see here that I cannot use this dot to dereference a null object.
In other words, if a variable does not currently hold a value, it is given a special value called null, right? So this is for objects. It's typically a dummy value that's meant to be replaced later. It is not legal to use a dot notation on a null value. Null is not an actual object, so it has no methods or data. Trying to use it causes what's called a null pointer exception, as we saw in the demo. You can make your code safer by checking for null values. So just like with primitive data types, we can use comparisons to check if a variable is null.
So let's look at my little demo again, and what I've done here is I've just said if blanks at I is equal to null, then it's going to go ahead and print out null, otherwise it'll print out blanks at I to uppercase. And I told you it's not legal to use dot notation on a null value, but that's not what's happening anymore. So let's give this a shot. And I see it's going to print out null, and then Grace in all uppercase, and then null, and then Hopper in all uppercase, and then null. So everything worked out the way I liked it to. All right.
So just to give you a sense of what was really important in this video, you'll notice that there was a lot of new vocabulary words. Things like object with a capital O, null, shadowing, the this keyword, class, and constructor. So for this video, it's really important that you know what all of these words mean, that you can define them, because that's going to make it easier to talk about your programs later on as we move on with developing, creating more of our objects and then using them in different ways. Right? Other than that, that's all I have for you. Thanks for watching.